Challenge, where I will be talking about how to design and build a sturdy and reliable competition robot. One of the beautiful parts about FIRST Robotics and FLL is the absolute diversity at each of the events. Not only of the students, but also the creative and outside-of-the-box thinking for the designs that they come up with. There are infinite ways to build a competition robot, and no one way is correct. But over the years, I have found a number of tips and tricks to make a robot more reliable at competition. The first thing that you're going to want to do before you start building is to have a brainstorm session with your team. This is the point where you will focus on discussing which missions you're going to want to focus on first, and the possible missions that you can use to collect the points. Try not to limit yourself on how many missions you can complete, but don't overwhelm yourself either. Take it just one step at a time. Some of the design features you'll want to consider would be the general location where you place the motors on the robot. What missions can you do with the same equipment without needing to stop and reset? And what bases are you going to want to use? Let's start with the base, the heart of the robot build. The most basic robot base contains two motors controlling either side of the robot, typically either wheels or treads. The robot brain, attachment motors if attached, and any Lego that is holding these pieces together. Under many cases, teams also attach various sensors and other devices to their base for better accuracy during their programs. When designing your base, make sure that you have easy access to the robot brain to run programs and replace or recharge batteries if at all needed. You'll also want to ensure that you have space for the wires to motors and sensors. The motors go to the lettered ports, typically driving with the left as B and the right as C, and the sensors plug into the numbered ports as well. The wheels also play a major role in the design of the robot base. Larger wheels are faster, but they can be less accurate and have less power than their smaller counterparts. Treads are another option, but they can often be tricky to use and implement into a design without experience, but they do allow for easy travel over rough terrain if needed. However, treads do eliminate the need for back wheels, which can be difficult to design in many cases. One of the most common wheels are the casters, which work great until you need to travel over anything. Just a quick personal note on casters that I have found through my personal experience is sometimes dust and dirt can get caught up inside of it, so you can push it out of the socket and clean it for better accuracy. At competition, we did this between each match to ensure that the robot was ready. The next step involves looking at each of the missions you plan to complete and think of the best locations on the robot to attach motors that will drive other elements of the robot you can add and remove throughout the competition depending on the mission you're running. Don't be afraid to experiment with gears, gearboxes, or other mechanisms either to help you position your pieces where they need to go. The final part of designing a robot is the attachments. These are the parts of the robot that will be added and removed from your robot throughout the match in order to complete different missions. These generally get attached to the attachment motors for movement, but they can be whatever you want. When designing these attachments, look for ways to combine them with multiple missions in order to be more efficient with points and time if possible. Get creative with your designs, but try not to overcomplicate everything in the process. Also, something you might want to consider is how simple it would be to add and remove these attachments to the robot for the next program to run, and to ensure that it will fit within the launch zone before it's gone. Other tips and tricks that I have found include utilizing the drop test on every element of your robot. This means that once something is built, you'll want to lift it at about a foot from the ground and drop it to make sure that nothing is going to get accidentally disassembled and it can survive the travel to and from competition. If you mention this to judges during the robot design portion, it shows that you look for durability in your designs. Also, if students are torn between multiple ideas for a piece, consider building a rough idea for both of them and testing them on the robot. In many circumstances, students can find that one is clearly better than another, or that there is a way to get the benefits from both. I hope that this video has been helpful to you in learning about how to build a sturdy and reliable competition robot for First LEGO League Challenge. If you have any questions or if I missed anything that you think I should have included in this video, please leave them in the comments down below. It would be greatly appreciated. Also, if you'd like to support this channel and see more content about FIRST Robotics, please subscribe, leave a like, and ring the bell, because it really helps me see how I'm doing. Finally, I want to see who I'm reaching with these videos. So if you're with the team and have the ability, please leave the team name, number, and general location in the comments so I can see. Thank you so much for watching. Bye!